Today we are looking at geometric probability. Please copy down the standard benchmark indicator at the top of a clean page in your notebook. The student will predict the probability of outcomes of simple experiments and do the experiment. You can pause the video here to copy down the SBI. Geometric models of probability. Some events and outcomes are not always single items that can be counted. For situations such as carnival games and dartboards, the probability of an event happening depends upon the area of portions of a figure. If you can determine each area within the figure, you can determine the probability of the situation. A carnival game has a dartboard with a pattern like the one at the right. What is the probability of hitting a shaded square? There are 30 square units in the rectangle. 18 of them are shaded. The probability of hitting a shaded square is 18/30ths, or 3/5 when simplified. Try it. Use the game board to find each probability. So the first thing we have to figure out how many squares we have. So there are 16 squares on our game board, and each square is of an equal size, so each square has an equal chance of being landed on. So for A, what is the probability of a marker landing on the letter W? In this case, there are 4 W's. So there is a 4/16 or 1/4 chance of the marker landing on a W. Second, for B, what is the probability of a marker landing on the letter O? So if we look, there are 3 O's. So the probability of a marker landing on an O is 3/16. For C, what is the probability of a marker landing on the letter R? In this case, if we look, there are 5 R's. So the probability is 5/16. Finally, for question D, what is the probability of the marker landing on the letter D? We can see the 4 uncircled shapes we have left are all D's, so there's a 4/16 or 1/4 chance of it landing on a D. Suppose you drop a token on each shape. Find the probability of the token landed on the shading area. For E, we have 7 different sections, all of them equal size, and 3 of them are shaded, so we have a 3/7 chance of the token landing on the shaded area. For F, we have 8 sections equally sized again. 4 of them are shaded in, so it becomes a 4/8 chance, or 1/2 when we simplify. For G, we have 6 sections equal size. 2 of them are shaded in, so it's 2/6 or 1/3. A skydiver jumps out of a plane above an area represented by the map to the right here. What is the probability that the skydiver will land in water, and what is the probability the skydiver will land on land? When you're working with something that is not equally shaded here, if you look here, the sections will match up if we add them to each other. So I'll draw some arrows to show you what I'm talking about here. So to make this easier for us, we want to get full squares. So if you look at the very top shaded square, that shaded area will fill in the white shaded area in the bottom left square. Next, the little tiny shaded area just below that, which I will circle, is going to fill in the little white area in the second square. Finally, the shaded area circled by the red will fill in the area to its left. So that way we can get some full squares. So I'm going to erase the circles and show you the shaded in squares now. So now if you look, we're going to have 6 full squares that are shaded. I'm going to number them now. So now we know there's a 16th, because we have 16 possible squares, chance of the skydiver landing on the water. Which simplifies down to 3/8. That means, conversely, there's a 10/16th chance of landing on land, which simplifies to 5/8. So, as you can see, there are a lot of different ways to determine geometric probability. Sometimes you have to be a little creative and mentally moving pieces of it around to figure out the possibility. So, please make sure everything is copied down and then glue this page in your math notebook.